Our next topic is two cells in parallel combination. Two cells are said to be connected in parallel between 2 points A and C if their positive terminals are connected at one point and their negative terminals are connected at other point. Let E1, E2 be the EMFs of the two cells and R1, R2 are their internal resistances. Let I1 and I2 be the current flowing from two cells towards B1 and I be the current flowing out of B1. Then I1 plus I2 is equal to I. Let VB1 and VB2 be the potentials at B1 and B2 respectively, and V is the potential difference between B1 and B2. Then V will be equal to VB1 minus VB2. Potential difference between 2 points is equal to potential at first point minus potential at second point. Now, potential difference across the terminals of first cell is equal to potential difference across terminals of second cells because two cells are connected in parallel. So, for the first cell, potential difference between B1 and B2 is equal to terminal potential difference of the cell. This is equal to E1 minus I1 R1. Taking I1 R1 to this side and V to this side, I1 R1 is equal to E1 minus V. Therefore, I1 is equal to E1 minus V upon R1. Now, for the second cell, potential difference between B1 and B2 is equal to terminal potential difference of second cell E2 minus I2 R2. Therefore, I2 become E2 minus V upon R2. Now, as I1 plus I2 is equal to I, value of I1 is this, value of I2 is this. Therefore, as I is equal to I1 plus I2, putting the value of I1 and I2. This can be written as E1 upon R1 minus V upon R1. This can be written as E2 upon R2 minus V upon R2. Rearranging them, this becomes E1 upon R1 plus E2 upon R2 minus V upon R1 minus V upon R2. Taking the LCM of R1 and R2 and solving this, we get this. Taking the LCM of R1 and R2 and solving this, we get this. Taking this term to left hand side and I to right hand side. When we take this factor to the right hand side, then R1, R2 goes on the upper side and R1 plus R2 goes on the lower side in multiplication. Therefore, on solving this, we get V is equal to E1 R2 plus E2 R1 divided by R1 plus R2 minus I into R1 R2 divided by R1 plus R2. If the parallel combination of two cells between B1 and B2 is replaced by a single cell of EMF E equivalent and resistance, internal resistance R equivalent, which send the same current I from B1, then potential difference between B1 and B2 will be V is equal to E equivalent minus I R equivalent. This is the terminal potential difference of single cell. Now, from 2 and 3, as the left hand sides are equal, therefore right hand sides are also equal. Therefore, E equivalent become equal to this. Equivalent is equal to E1 R2 plus E2 R1 divided by R1 plus R2. I is common. R equivalent become equal to R1 R2 divided by R1 plus R2. Now, E equivalent is equal to E1 R2 plus E2 R1 divided by R1 plus R2. Dividing numerator and denominator by R1 R2. Then this remains unchanged. Numerator become E1 upon R1 plus E2 upon R2. Denominator become 1 upon R2 plus 1 upon R1. And as R equivalent is equal to R1 R2 divided by R1 plus R2, its reciprocal 1 upon R equivalent will be R1 plus R2 divided by R1 R2. On solving this, this becomes 1 upon R2 plus 1 upon R1. Now, from 4 and 5, equivalent upon R equivalent. This can be obtained by multiplying 4 and 5. Multiply करेंगे 4 को और 5 को, तो ये हो जाएगा multiplying left hand side by left hand side and right hand side by right hand side. We get E equivalent upon R equivalent is equal to E1 upon R1 plus E2 upon R2 and 1 upon R equivalent is equal to 1 upon R2 plus 1 upon R1, या इसको हम ये भी लिख सकते हैं 1 upon R1 plus 1 upon R2 भी लिख सकते हैं. If n cells of EMF E1, E2, En and internal resistances R1, R2, Rn are connected in parallel and their equivalent EMF is E equivalent and their equivalent internal resistance is R equivalent, then 1 upon R equivalent will be equal to 1 upon R1 plus 1 upon R2 plus 1 upon R1, because if there were two cells, then equivalent internal resistance was 1 upon R equivalent was 1 upon R1 plus 1 upon R2. Similarly, as the equivalent upon R equivalent for two cells is E1 upon R1 plus E2 upon R2, for n cells will be equivalent upon R equivalent is equal to E1 upon R1 plus E2 upon R2 plus up to so on En upon Rn. If two cells connected in parallel are of same EMF E and same internal resistance R, then from the equation 4, E1 is equal to E, R2 is equal to R, E2 is equal to E, R1 is equal to R, then equivalent become ER plus ER upon R plus R. This become equal to E, and from this R equivalent become equal to R upon 2. This means if two cells of same EMF and same internal resistance are connected in parallel, then their equivalent EMF is equal to EMF of single cell, and their equivalent internal resistance is half of internal resistance of one cell. If we have three resistances, or if we have three cells of EMF E1, E2, E3 and internal resistance R1, R2, R3 are connected in parallel, then equivalent upon R equivalent will be equal to E1 upon R1 plus E2 upon R2 plus En upon Rn, and 1 upon R equivalent will be equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. And from this we can also write equivalent of three cell will be E1 upon R1 plus E2 upon R2 plus E3 upon R3 upon 1 upon R1 plus 1 upon R2 plus 1 upon R3.